Look at this house. It looks like every other house in suburbia. It's got a lawn, a two-car garage, and an AC unit humming on the side. But if you look closer, right next to that AC, there's a sleek liquid-cooled metal box. Inside that box isn't a compressor. Inside are 16 of Nvidia's most powerful next-generation enterprise GPUs. This single suburban home is currently running complex AI inference workloads for users halfway across the world. Right now, tech giants like Meta, Google, and OpenAI are facing a crisis that nobody is talking about. It's not a software problem, it's a power problem. They are literally running out of electricity to train and run their AI models. And their solution? It isn't building another massive multi-billion-dollar data center in the desert. Their solution is your house. Nvidia has quietly teamed up with a massive home builder called PulteGroup and an energy smart panel startup called Span. They are running pilots right now to do something radically insane: decentralize the AI grid. Instead of building one massive AI factory that takes 7 years to approve, they want to bolt mini AI data centers directly onto thousands of suburban homes. And the wildest part, the economics actually make sense for the tech companies and for the homeowners. In this video, we are breaking down the secret bottleneck threatening the entire AI revolution, how Nvidia is trying to turn your neighborhood into a multi-gigawatt supercomputer, and exactly what you get if you let them bolt a $250,000 AI node to the side of your house. Let's get into it. To understand why Nvidia is looking at suburban backyards, we have to look at the massive wall the tech industry just slammed into. For the last few years, the AI race has been simple. Bigger is better. More data, more GPUs, bigger clusters. We went from clusters of 10,000 GPUs to companies talking about building 100,000 chip supercomputers. But here's the problem: these systems are incredibly hungry. A single modern AI data center can require as much electricity as a small city. If you want to build a hyperscale data center today, you don't just buy land and plug it into the wall. You have to go to local governments, negotiate with utility companies, get environmental permits, and literally wait for new power lines or power plants to be built. The timeline? Anywhere from 5 to 7 years. But AI demand isn't waiting 5 to 7 years. Wall Street wants results every quarter. AI models are being deployed now. So, the tech industry is staring at a terrifying bottleneck. They have the money, Nvidia has the chips, but the power grid literally cannot give them the juice fast enough. And that's when some clever engineers realize something fascinating about the way our world is wired. Think about your local neighborhood. When the developers built it, they had to wire it for the worst-case scenario. They assumed every single house would have the AC blasting, the electric vehicle charging, the dryer running, and the oven on all at the exact same time. Because of that, residential neighborhoods are wired with an immense amount of electrical capacity. But day to day, most of that capacity sits completely idle. Most homes only use about 40% of the total electrical power their lines can actually handle. That is millions of gigawatts of unused, already permitted, already connected electrical infrastructure just sitting there. Enter Nvidia, Span, and PulteGroup. Instead of waiting 7 years to build one massive 100-megawatt data center in the middle of nowhere, what if you took that compute capacity, broke it up into thousands of tiny pieces, and scattered it across a suburb? Span, the company that makes those high-tech, intelligent electrical panels, realized they could manage this load perfectly. They can monitor a home's power usage in real time. When the home doesn't need the power, the AI node eats it. According to reports from these pilot programs, Span believes that just 8,000 of these residential nodes working together can match the computing power of a massive traditional 100-megawatt centralized data center. And because the houses are already built, the power lines are already in the ground, and the internet cables are already laid, they can deploy this entire distributed network 6 times faster and at 1/5 the cost of building a traditional data center. Okay, so what is actually inside this box? Because when I say mini AI data center, I'm not talking about a beefed-up gaming PC. This is a serious, industrial-grade enterprise server packed into a weatherproof, fanless enclosure. Reportedly, the current XFRA node configuration being tested is built on a liquid-cooled Dell PowerEdge system. Inside, it holds 16 Nvidia RTX 6000 Blackwell Server Edition GPUs, 4 AMD EPYC CPUs, and a staggering 3 terabytes of RAM. To put that in perspective, this is a piece of hardware worth roughly $250,000, bolted right to the outside wall of a suburban home, and it's not doing the heavy foundational training of AI models that still requires massive centralized clusters. Instead, these suburban nodes are dedicated to inference. Inference is the actual use of AI. Every time someone asks an AI to write an email, generate an image, or write code, a server somewhere has to run that request. That is inference. And because inference needs to happen fast and close to end users, putting these nodes right in the middle of populated suburbs is actually an engineering masterstroke. It reduces latency, because the compute is happening right down the street from the people using it. Now you might be thinking, why on earth would I want a $250,000 supercomputer humming outside my bedroom window? Won't my electric bill be $1 million? This is where the business model gets brilliant. Tech companies are so desperate for infrastructure that they are willing to completely subsidize your lifestyle to get it. Let's look at the trade-offs of becoming an AI host home. In a traditional home, your utility bills fluctuate, power outages can knock out your lights, and your house is just a passive consumer of energy. You pay, they give. But in the Nvidia and Span pilot model, your house becomes a digital landlord. You are leasing a tiny footprint of your property to the AI economy. In exchange, the pilot programs are exploring incentives like a locked-in flat-rate utility bill. Imagine paying a flat $150 a month for all the electricity and ultra-high-speed fiber internet you can use, regardless of how much the AI node is pulling. Free infrastructure. To make this work, they install a premium Span smart electrical panel and a massive backup battery system at no cost to you. Grid resiliency. If the main power grid goes down, your house doesn't lose power. The smart system automatically disconnects from the grid and runs your home off the backup batteries. For a lot of homeowners, getting free green energy upgrades, a battery backup system, and incredibly cheap, predictable power is a no-brainer. But let's be real for a second. This sounds amazing on paper, but physics always wins. There are some serious hurdles this model has to clear before it goes nationwide. First, heat. 16. Enterprise GPUs running at full tilt generate a massive amount of heat. These nodes don't destroy heat, they just move it. While the units are liquid-cooled and fanless to keep them silent, that heat has to go somewhere. Some early designs are looking at routing that hot liquid exhaust into the home's water heater or HVAC heat pump, which is genius if it works, but if it doesn't, you basically have a giant space heater permanently attached to your house in the middle of July. Second, logistics and security. If a server breaks down in a traditional data center, an IT tech walks down aisle 4 and swaps a part in 5 minutes. If an XFRA node glitches in a suburb, a technician has to drive a truck out to a residential neighborhood, deal with the homeowner's dog, and fix a $250,000 machine in the pouring rain. Not to mention, these boxes are vulnerable to physical theft or vandalism in a way a secure data center never is. What we are seeing here is a fundamental shift in how civilization deploys technology. For decades, the cloud was something far away, massive anonymous warehouses in Iowa or Virginia. But as AI becomes embedded in everything we do, the cloud is coming home. Suburbs might not just be residential zones anymore, they are on track to become the physical backbone of the AI grid. Nvidia isn't just a chip company anymore, they are literally rewriting the rules of infrastructure. So, I want to hear from you. If Nvidia or a home builder knocked on your door tomorrow and offered to install a liquid-cooled AI node on your house, lower your electric bill to a flat rate, and give you a free backup battery system, would you do it? Or does the idea of a mini data center on your wall freak you out? Drop your thoughts in the comments below. If you found this video interesting, hit that like button, subscribe for more deep dives into the tech shaping our future, and I'll see you in the next one.